In college algebra today, we introduced inverse functions. And I found this movie problem. We have a list of movies on the left, and the year it came out, and how many Academy Awards it won. And so right down here where you see F is the listing of its coordinates. So if we can call the movie title the X value and the number of Academy Awards the Y, is it a function? And I would say yes, because no movie title is repeated. No X is repeated. There's this other thing called the inverse. That's the title of today's lesson. And what it does is it flips the X and the Y. And so if we take the inverse of those movie coordinates, we now have this inverse down here. And then same question, is it a function? This time we're going to say no. 11 is repeated 3 times. So when we find an inverse, we're going to use it in different ways for the rest of the year. You have to determine if it's a function, and just because the original was a function doesn't mean the inverse is a function. So one other thing that's interesting is to determine if another function is the inverse of the function. So we have f and g. We need to determine if g is the inverse of f. You do that by finding f of g and g of f like we did in the last lesson. You do the composite. We're going to start by writing function f, and you see a x, so we're going to put that right there. And then write the rest of function f, and the 300s cancel, we get x. For g of f of x, we're going to do vice versa. We're going to take this portion and plug it right there. So we have x minus 300 plus 300. 300s cancel again, and we get x. Anytime both directions give you x, you are then allowed to say that one is the inverse of the other. So therefore, g of x equals f negative 1 of x. G is the inverse of f. Let's try another one. Flip to the back. It talks a little bit about domain and range here. If you're finding the inverse, the domain of f is kind of the exact opposite for the inverse. It's the range. So they are equivalent when you go domain to range. But number 2, we're going to do the same exact thing we did a second ago. We're going to find f of g, and then we'll find g of f. So I'm taking this, and I'm plugging it right there. Fives cancel, and we end up with x. Find g of f, and I'm putting 5x in place of the x in function g. The 5s cancel, and we get x again. G is the inverse of f. Let's do one more. Show that g is the inverse of f. So yet again, f of g. We're putting this value right there. And then we write the rest of function f. Looks like it's not going to happen at first, but just go in small steps. The 3's cancel out. The 2's cancel out, and we get x. For g of f, you're going to go in reverse again. We are taking, I need another color. We are taking 3x plus 2, and we are putting it right there. I can't mess with the 3 yet. I got to deal with the 2's first. So we end up going 2 minus 2, and they go away. Now I can cross out the 3's, and we get x. G is the inverse of f. And that's it. I'll see y'all later. Bye.